Hello again, ladies and gentlemen. This is Mr. Donahue going over the 5.5 calorimetry problems, starting with question number 17. All right, so the first couple problems are just kind of definition things that, are you paying attention to the details? Heat capacity. The units for that are joules per Kelvin or joules degrees Celsius. So what that's really kind of saying is, like, if we were to picture we had a calorimeter filled with H2O, like in a simple calorimeter that we'll do in class or something. Specific heat for water, which is usually like a little c, is 4.18 joules per grams degrees Celsius. That's saying, all right, if you know how many grams of water you got, you can figure out how much heat you need to change that temperature. Usually what's called big C for heat capacity is, well, all right, no, how much for this whole system? All right, if this whole system were to change X amount of degrees, how much heat is that? So that's just saying, all right, joules per degrees Celsius or Kelvin, whichever one. Remember that one change in Celsius is the same thing as changing one in Kelvin. All right, now the next problem is the same but different. All right, this says specific heat of specific heat. Oh, Donnie, you messed up. Yep, all right. Keep pointing it out. For this one, we kind of talked about in the last problem. It's joules per gram degrees Celsius or gram Kelvin. So choice C would be the right answer. Take a look at 19. It says temperature of a 12.58 gram sample of calcium carbonate is increased from this temperature to that temperature. If the specific heat of calcium carbonate is this, how many joules of heat are absorbed? All right, so first formula that you're going to remember or need to remember is that Q equals MC delta T, where M is the mass, C is the specific heat, delta T is the change in temperature, right? Change in T. And the Q is joules, right? It's how much heat. So we take a look. Q is what we're solving for, so Q equals M, 12.58 times C, which they give right here is point. That's an ugly 8, right? Not bad. 0.82 joules per gram Kelvin times the delta T, which would be the change in those two temperatures, right? The final minus initial, 38.2 minus 23.6. And then you just do the maths, right? Now it's just the maths. You plug it in, make sure you're using the calculator correctly, and you should get choice E as your final answer. That's it. All right, 20. Same problem, but different. All right, so a sample of calcium carbonate absorbs that much heat. So all right, what do I know? I know my Q, upon which the temperature of the sample increases from that to that. So I know T initial, I know T final, so I can figure out the change in T. It says what the specific heat is, right? So these are all things that they tell me, and they want to find the mass. So I know, well, looking at this, I know I'm going to use Q equals MC delta T formula, and I got to solve for the mass. So divide each side by C delta T, and you get mass equals Q divided by C delta T, right? The Q here is that's my Q. And it's just kind of plug and chug, right? Which I guess I will show despite me being reluctant. Over the specific heat, which they told me is 0.82 joules per gram Kelvin, times change in temperature, which looking at and doing it in my head, 7.4 degrees. So you should get the answer. Should be choice C, as in Charlie. All right, problem 21. An 8.29 gram sample of calcium carbonate absorbs that much heat upon the temperature of the sample increases from 21.1 to 28.5. What is the specific heat of calcium carbonate? So again, they give us Q, they give us delta T, and they want us to find the little c, and they give us the mass, right? So that's our mass. So we're going to use this formula again. but we got to solve for C. So divide each side by m delta T. We get C equals Q divided by m delta T. All right, so now it's just kind of plug and chug. Plug those numbers in, get the answer. I know you think I'm getting lazy, because I am. You just plug in those numbers, beep bop, boop, enter the answer, and I didn't even circle the final answer. 21 should be choice B. Final answer is B. All right, 22. Specific heat of liquid bromine is this. How much heat is required to raise the temperature from of 10 milliliters of bromine from that to that? It gives you the density. All right, so we know we're going to need this formula again. Right? They give us the C. They want to find Q. They give us milliliters, and they give us density. So we know the change in temperature is right here. So the first thing we're going to have to figure out is, well, what's my mass? And that's where the density formula comes into play. You know, density is mass over volume, so mass has to equal density times volume. They give us the density right here, so it's 3.12 grams per milliliter times by 10 milliliters. So we get 31.2 grams. And that's our mass. So that gets plugged in to here. Now it's just plug and chug, right? Solve for Q. Answer 22 should be B. All right, last one. 23, the combustion of titanium with oxygen produces titanium dioxide, equation given below. When 2.060 grams of titanium is combusted in a bomb calorimeter, the temperature of the calorimeter increases from 25 degrees to 91.6 degrees. In a separate experiment, the heat capacity of the calorimeter is measured to be 9.84 kilojoules per Kelvin. The heat of reaction for the combustion of 1 mole of TI in the calorimeter is blank. So this is a multi-step problem, right? So we want kilojoules per mole. So the first step would probably be to find kilojoules, right? Second step would be to figure out, well, how many moles is that? Third step, well, if we want kilojoules per mole, you got to do step 1 divided by step 2, right? And then I always save this for the last step. Is it going to be positive or is it going to be negative? Right? And I do that by looking at the temperature. So first step, how do I figure out kilojoules? Well, I got to do Q equals the delta T times the heat capacity, right? So the change in temperature be 91.6 minus 25. I'm ignoring sig figs for the time being because I'm lazy. Times 9.84, and I get 655 kilojoules as my Q. Second step, figure out how many moles. All right, well, how do I do that, Donnie? Well, they gave me grams of TI. So I just got to convert grams of TI by dividing it by the GFM of TI. So I get 2.060 grams divided by, look up TI's GFM, it's 47.9 grams per mole. And I get 0.0430 moles. Right, so now I'm on my third step. I want kilojoules per mole. So I got 655 kilojoules per 0.0430 moles. So do the math there, and I get 1.52 e to the fourth kilojoules. Now I'm going to figure out my sign, right? Is it going to be a positive or a negative? Well, the temperature of the bomb calorimeter went up. So I know that the reaction is giving off heat, it's losing heat. So it's got to be a negative 152 times 10 to the fourth, which would be choice E. Feel free to go back, rewind, pause, replay. Hope you found this helpful. Hope with a little practice you guys become experts, and I will see you next time.